हम लोग ने लॉजिस्टिक रिग्रेशन देखा था, राइट? हम लोग ने मल्टी क्लास लॉजिस्टिक रिग्रेशन भी देखा, जहाँ पे तुम्हारे पास एक से ज्यादा फीचर होता है, उसको कैसे डील करेंगे। तो आज मैं दो क्लास को कंबाइन करूंगा। एक है क्लासिफिकेशन मेजर, बहुत ज्यादा बड़ा नहीं, 30 मिनट्स का टॉपिक है, उससे ज्यादा भी नहीं। और दूसरा है फीचर स्केलिंग। ये दो टॉपिक आज हम कवर करेंगे, ठीक है, आज के सेशन में स्पेसिफिक। लेट मी शो यू व्हाट आर द एजेंडा फॉर टुडे। सो we'll see what classification measures are. जैसे हम लोग ने देखा था रिग्रेशन मैट्रिक्स में, we have this mean absolute error, mean squared error, root mean square error, right? ऐसा था हम लोग पास R2 स्कोर, R2 एडजस्टेड। इससे बेसिकली मेरे को पता लग रहा था मेरा रिग्रेशन कितना अच्छा है, ठीक है, कितना एक्यूरेट है, कितना करेक्ट है मेरा रिग्रेशन। सो सेम थिंग वो रिग्रेशन के लिए था। क्लासिफिकेशन मेजर इज फॉर क्लासिफिकेशन एल्गोरिथम। जैसे कल हमने क्लासिफिकेशन एल्गोरिथम देखा, दैट वाज योर लॉजिस्टिक रिग्रेशन। अब वो तुमने बहुत अच्छे से लॉजिस्टिक रिग्रेशन कर लिया, वेरी नाइस। अब क्या होगा? नाउ यू वांट टू नो कि मेरा एल्गोरिथम कितना अच्छा से क्लासिफाई किया है, ठीक है। सो वी विल सी ऑल दोस थिंग हियर, we'll see all those thing here. Till then, let's do what? We also see what this feature scaling is. थोड़ा सा mathematics deal करेंगे, and we'll head on to the implementation. First of all, just tell me if it is visible or not. Let me show you this. Just tell me if it is visible or not. ठीक है, visible. चलो पहले ये क्या है, इसको बाद में डील करते हैं। Let's head over to some of the, एक मिनट। So जैसे हम लोग लास्ट क्लास में देखा, like as we have seen in the last class, perfect, we had some kind of classification algorithm. अब उस classification algorithm का product क्या था? It was either, let's say, if you have some set of input, when you pass it through some kind of classification algorithm, classification algo, what was the output? It was either some kind of, let's say, class A and some kind of class B. यही दो हो रहा था। अभी सिर्फ हम बाइनोमियल के लिए बात कर रहे हैं। इसी तरह से था कुछ, या तो वो पर्टिकुलर इनपुट क्लास ए में लाई करेगा या क्लास बी में लाई करेगा, राइट? यही तो था। अब ऐसा भी तो हो सकता है, फॉर एग्जाम्पल let me say something like this, that let us say you have two classes. You have your class A, you have your class B, ठीक है? You have these two classes. So let us assume that you let 100 data points are there, ठीक है? Let there are 100 data points, on of which I am saying 95 of them belongs to this class A and only 5 belongs to this class B, ठीक है? मैंने क्या बोला कि we have this 100 data points and out of which only 95 belongs to this class A and 5 belongs to this class B. So the very first classification measure, which is known as your accuracy, very simple. If I'll show you here, you have this very nice definition. Accuracy, it just reflects the overall proportion of total correct prediction. Like तुमने जितना prediction किया है उसमें से कितना correct है. For example, let me show you through an example. For this example only, let us take it for only this example. This 95 data point belongs to class A and 5 data set belongs to class B. If I say, if my output is A, so can I say this model has an accuracy of 95%? For all output, I'm only getting A. सारे output के लिए it could be A, it could be B. ठीक है, but for all values I'm getting only A. So I can say my accuracy is 95%. सुनने में अजीब लग रहा है, बट इस एग्जाम्पल के थ्रू मैंने एक चीज में दोनों चीज डिस्कस कर दिया है, एक्यूरेसी होता क्या है और दूसरी चीज ये कि एक्यूरेसी क्यों एक अच्छा मेजर नहीं है. बिकॉज कभी कभी जब डेटा इतना ज्यादा वैरी करता है, जब इतना ज्यादा डेटा वैरी करता है, जैसे 95 डेटा क्लास ए में आ गया और 5 से क्लास बी में आ गया, सो ये जो पहला क्लास है ये आउटवे कर देता है दूसरे क्लास को. Therefore, accuracy is not a very nice measure to go with. Huh, data, whenever your data is not skewed, let me use this word. If data is not skewed, let me have. If your data is not skewed, use it only for this case. बहुत ज्यादा मेरे को कुछ इससे पता नहीं लगता है, because we'll see what is a better matrix, a better metric to actually judge. ठीक है, we'll see. Suyash, I guess ये तुम्हारा first session है ना? Just write in the text if it is your first session. अच्छा. So if you go by definition, let me show you this definition. It just says the overall proportion of. अभी ये सब क्या है? Forget about it. अभी ये सब क्या है? Just forget about it. I'll tell you. But for the sake, let us have this intuition in mind that your accuracy just reflects what is the overall proportion of the correct prediction. ठीक है? Right. Let us say something like this. Let us say something like this. This was your first matrix in which you have seen whenever your data is skewed, that means somehow which is not distributed properly, like 95% was for only first data point and 5 was only for 5 was for class B. तो डेटा यहाँ पे अच्छी तरह से क्लासिफाइड नहीं है, लाइक 95 वाला डेटा क्लास बी को ओवर पावर कर दे रहा है. So in such cases, going with accuracy is not a very good option. We have this another component which is known as precision. If I go with the definition, if I show you this definition, precision, it just measures the proportion of positive prediction that were actually correct. What do you mean by this? What do you mean by this? Let us say something like this. Let there be a data set. Let there be data set something like this. If you have this class A and you have this class B. So initially, let us have a very balanced data set that 50 data points belong to this class A and 50 data point belongs to this class B. ठीक है? Can I say? Give me a thumbs up if it makes sense. Vanshika, Sashank, okay, Muhammad, Suyash, Shreya. We have this balanced data set. Now let's do what? Let's have a model. Yeah, when let's say you have this xi, let this be any data set. If I pass it using the algo, and this xi is what? This belongs to your class A. ठीक है, this belongs to your class A. Class A में जितने भी 50 elements है ना, इसमें से कोई एक पॉइंट मैंने उठाया, उसको एल्गोरिथम के थ्रू पास कराया, and what it gives me 40 that are actually class A. Oh, just a second. ये क्या हो रहा है यार?
सिर्फ श्रिंजय,
हाँ
प्रिसीजन मतलब ऐसा तो नहीं है ना कि मतलब प्रिसाइज वे में वो 50-50 इसी
नहीं,
वे में।
प्रेसिजन का मतलब 50-50 नहीं होता, मैं बता रहा हूँ क्या हो रहा है. लेट अस से that 40 of them were actually in class A, and अब एरर होता ही है, एरर हमेशा होता है. 10 of them were from of class B. ठीक है, 10 of them was for class B. प्रेसिजन का मतलब वही होता है, बट यहाँ पे हम एक दूसरा इंट्यूशन फॉलो करते हैं. Let us do it for some other. Let this XA is from class B. If I pass this from algorithm, हमारा algorithm says something like this. Let us have that 5 were actually in class A and 45 were in class. These are what? These are prediction. ये prediction आया, right? ये prediction आया. ये prediction आया. Correct? अब let me also help you out with the definition थोड़ा सा. See, अगर if I show you this, let us have something like something as simple as this example only. Let me show you. हाँ, अब visible. अब can you actually tell me कि out of all class A, total class A कितना है? 40 plus 10, because this xi is what? From class A only ना, ये class A सही है. क्लास ए में टोटल है 40, देन 40 and 10, 50 आउटकम्स, और इस 50 आउटकम में से सिर्फ 40 ही करेक्ट है. तो ये प्रेसिजन इज व्हाट? 40 over 50, 4 over 5, 4 by 5. This is the precision. If I have to talk about this, out of all class B, only 45 is for class B. सिर्फ 45 ही क्लास B से बिलोंग कर रहे हैं, बाकी 45 plus 5 are something जो क्लास बी के होते हुए भी क्लास बी नहीं प्रिडिक्ट कर पाया. तो दिस इज 45 by 50. दिस इज योर प्रेसिजन. अब ये एक्यूरेसी और प्रेसिजन जो दोनों, ये दोनों मेट्रिक्स है, दीज आर डिफाइंड फॉर क्लासेस. व्हाट डू आई मीन बाय दिस? आई हैव टू राइट समथिंग लाइक दिस, दैट माय प्रेसिजन फॉर क्लास A was 4 by 5 and my precision for class B was 45 over 50. If you reduce it, you will get your value. So this is how your precision is defined. This is how your precision is defined. Okay? Let me also show you something. I'll take now we'll get back to the most important matrix which you should know. That is known as confusion matrix. It is known as confusion पहले इसको यूज करने के पहले we'll use the same example. ठीक है? Let us have your class A as our input. If I pass it in our classification algorithm, ठीक है? Let us say 40 people and 10 people. These are my prediction. These are my predicted class. So I can say 40 people belongs to your class A. Let us say this algorithm predicted, and 10 people are from class B. This is what this algorithm predicted. ठीक है? Can I say like this? Obviously I can say something like this. अब if you could see here, just tell me one thing, just tell me one thing, that ये क्लास ए में बिलोंग करता है, ये क्लास ए में बिलोंग करता है, राइट? सो 40 पीपल बिलोंग्स टू क्लास ए, ये एल्गोरिथम ने प्रिडिक्ट करके तुमको दिया. सो आई कैन से these are my true values, these are my true values, these are what, these are my true value. 40, यहाँ मेरा 50 वैल्यूज थे, 50 वैल्यूज को मैंने एल्गोरिथम में डाला, इस एल्गोरिथम ने 40 को क्लास ए में क्लासिफाई कर दिया और कुछ एरर रखा, वो एरर था 10 के साथ उसने एरर कर दिया, कोई बात नहीं, नो इश्यूज, 20% के करीब एरर था इसका. बट if I'll use this intuition, there is something known as true positives. So these true positives are what? These are those values, like हम जब हम बाइनरी क्लासिफिकेशन हम देखते हैं, तो बाइनरी क्लासिफिकेशन में क्या होता है, या तो क्लास 1 होता है या क्लास 0 होता है. क्लास 1 is your positive value, this class 0 is your negative value. ठीक है, we'll use this concept. ठीक है, we'll use this. सुयश, लेट मी टेल यू वन थिंग, तुम काफी लेट ज्वाइन किए हो. तुम व्हाट्सएप ग्रुप में जाके यूट्यूब का प्लेलिस्ट का लिंक है, यू कैन फिनिश द लेक्चर्स जो हमने अभी तक कंप्लीट कर लिया है. ठीक है, टिल देन वी हैव दिस ट्रू पॉजिटिव. इफ आई टेल यू आउट ऑफ दिस वैल्यू, यहाँ पे ट्रू पॉजिटिव क्या है, लेट अस से क्लास ए इज पॉजिटिव, तो क्लास ए में से ट्रूली ये वैल्यू प्रिडिक्ट हुआ. आई कैन से दिस इज माई true positive, this is my true positive. Then what, then comes your true negative. अच्छा वेट, अभी ट्रू नेगेटिव नहीं डील करते हैं. लेट अस हैव फॉल्स नेगेटिव. सी ट्रू बिलोंग्स to this keyword, belongs to this class, false keyword belongs to your other class, positive means you have actually predicted it correctly, and your negative means you have predicted it wrong. So if I have to get what is false negative here, this is your false negative, so I can say 10 is your false negative. Let us have it for some other other class. Let us have your class B. If I put this value in some algorithm, you get these two outputs. Let us say 5 and 45. 5 are predicted wrong in your class A. These are predicted in your class B. These are your predictions. These are all your predictions. Now, just help me understand with one thing. If I use this example, what are my false negative, false positive, false positive? So let us use this keyword. अच्छा false है, तो false है यानी कि I have to go into those classes जो actually class B से belong करता है. False is for class B. ठीक है, क्लास बी में आते हैं, क्लास बी में आते हैं. अच्छा एक मिनट, सॉरी माय मिस्टेक. फॉल्स पॉजिटिव, लेट अस लुक फॉर दोज वैल्यूज which are class B, but using this algorithm they have been predicted for some other class. What I mean कि वो एक्चुअली इस क्लास में बिलोंग करता है, लेकिन हमने ये क्लास में प्रेडिक्ट कर लिया. That is what means by false positive. Let us see. यहाँ पे if you go by this example, you will have something as this. Your false positive 5, and then comes your false, sorry, true negative. Your true negative is 45. अगर तुमको थोड़ा सा कंफ्यूजिंग लगा हो समझने में, let me actually show you this screen, this topic. You may use these notation, true positive, true negative, false positive, false. मैं इसको कहीं डिफाइन किया हूँ? अच्छा, मैं इसको कहीं डिफाइन नहीं किया हूँ. ठीक है, let me define it for you. No issues. I'll keep it very easy. So you have this very first term, which is known as true positive. So true positive basically means, let us have only two classes, your positive class and your negative class. बाइनरी क्लासिफिकेशन में से दो ही क्लास हो सकता है, वंशिका, श्रेया, मोहम्मद, शशांक, या तो क्लास ए या क्लास बी, पॉजिटिव या नेगेटिव, कुछ भी कहो. सो योर ट्रू पॉजिटिव just says your model have correctly predicted positive class. जो पॉजिटिव क्लास था उसको एकदम करेक्टली प्रेडिक्ट किया है. तो सिमिलरली ऑन द सिमिलर लाइंस यू कैन हैव ट्रू नेगेटिव. That means your model have predicted correctly the negative class. Model correctly predicted. Mohammed, are you getting what I'm saying? Perfect. That means कि जो दूसरा क्लास मेरा बन रहा है, that is your class B. शशांक एक मिनट, उसको कितना अच्छे से प्रेडिक्ट किया है. Then comes your false positive. ये कंप्लीट कर ले शशांक, फिर बोलना, ठीक है? I'll give you the time. False positive just says कि your model incorrectly predicted a positive class. अगर तुम कुछ बुक्स अब देखोगे तो this is also known as type 1 error. This is also known as type 1 error. ठीक है, कुछ बुक्स में type 1 error के नाम से ही होता है. And there is this false negative. False negative. It means your model predicted a negative class. Model incorrectly, sorry. TLY, incorrectly a negative class. In some books, it is also known as type 2 error. हाँ, अब बोलो शशांक.
जी ये बोल रहे थे कि ट्रू पॉजिटिव मतलब ये कि जो बच्चे एक्चुअली क्लास ए में बिलोंग कर रहे हैं.
एग्जैक्टली. और ट्रू नेगेटिव मतलब जो एक्चुअली क्लास बी में बिलोंग कर रहे हैं. फॉल्स पॉजिटिव मतलब ऐसे बच्चे जो क्लास बी के हैं लेकिन वो ए में आ रहे हैं. बिकॉज मॉडल जब हम रन करते हैं तो कुछ ना कुछ एरर होता है ना, कुछ ना कुछ एरर होता है ऑब्वियसली. सो जैसे फॉल्स पॉजिटिव, मॉडल इनकरेक्टली प्रिडिक्टेड अ पॉजिटिव क्लास. दिस इज नोन एज टाइप 1 एरर. पॉजिटिव क्लास को प्रेडिक्ट करने में इसने गलती किया. सेम फॉल्स नेगेटिव, द मॉडल हैज इनकरेक्टली प्रिडिक्टेड अ नेगेटिव क्लास. मैं इसको एक एग्जांपल से बताता हूँ, एक और अच्छे एग्जांपल से. सो if I use that same matrix, I'll use that same matrix, let me use it for same. If you have this value with you, True positives are 40, true positives are 40, false negatives are 10, false positives are 5, true negative is 45. So a confusion matrix, if I have to make a confusion matrix, सी कंफ्यूजन मैट्रिक्स का एक पर्टिकुलर ऑर्डर होता है, इसका एक पर्टिकुलर ऑर्डर होता है. लेट अस से यू हैव दिस, अच्छा लेट मी डू, you have this predicted class. In predicted class you have some actual values which are positive, you have some actual negatives, ठीक है. Then comes your actual matrix. You have some positive value, you have some negative values. These are predictions, these are predicted, ठीक है. So the first row and first column will have the values which are truly positive, which will have truly positive. Then comes your false negative, then comes your false positive, then comes your true negative. So if you would like to add it up, you will have total number of actual positive value when you sum these, you will have total number of negative values when you will sum these. For example, for the above illustration which I have used, in which I have this matrix in which I said something like this. Let us have it for like this. So you have actual class A and your actual class B, right? These are my true positive. Let me not do. These are my predicted A. These are my predicted A. These are my predicted B. So out of all actual A, I have 40 such values which are actually A. 50 में से 40 ऐसे values थे जो actually A थे. But we have 10 such values on which we have falsely predicted as negative. Right? अगर तुम थोड़ा सा ऊपर देखोगे, this is what I mean. एक्चुअली में पॉजिटिव थे बट हमने उसको गलती से नेगेटिव प्रिडिक्ट कर लिया, ठीक है. देन वील यूज दिस 5 and 45. For class B, there was 5 such value on which we have predicted them as A, that is false positive, and then you are left with this 45. Make sense? अब ये कंफ्यूजन मैट्रिक्स को ऐसे डिफाइन किया गया है, ये कन्वेंशन. अब इसमें ऐसा कुछ नहीं है जो हम लोग चेंज कर सकते. इट इज हाउ इट इज डिफाइंड, ये ऐसे ही होता है. इफ आई शो यू दिस फिगर, see, if you could see, for two classes, species, ठीक है, you have some true positive, you have this false negative, you have this false positive and false negative. So all of these formula, like true whatever value, like accuracy is defined as total positive plus total true positive plus true negative, and you sum it over the entire data set. That is your accuracy. Then comes your precision. Precision is only your true positive divided by true positive and false negative, false positive. You sum it up. This is how they are defined. We have this another feature which is known as recall. This is known as recall. So if you take this example only, you can actually, we have this, for this data set, for this data set, what would be your recall? Recall would be also defined for some class A. Let us say your class A. So it says out of all 50 data set which are from class A, हमने सिर्फ 40 को ही accurately predict कर पाया. ठीक है, 40 over 40 plus 10, that means 40 over 50. ऐसे these are all just formula. मैं formula बैठ के नहीं कराने जा रहा हूं. मैं formula बैठ के नहीं कराने जा रहा हूं. You have this formula, you can put the values here, you'll get whatever you need. I'll give this, मैं ये send कर दूंगा group में. ठीक है. You have this FNR rate, you have this F1 score, which is very important. F1 score क्या है? F1 score क्या है? मैं बता रहा हूँ. F1 score is what? It is just the harmonic mean. It is just the harmonic mean. If I'll show you here, if you will see the formula, F1 score, if you could see the definition, this harmonic means balances the precision and recall, providing a single score. ऐसा एक single score दे देगा जिससे दोनों का काम हो जाए, precision and recall का. So what I mean, let us say, let P is the precision you get and R is the recall you get, what you get. So your F1 score is defined as 2 into 1 over 1 plus P plus 1 by R. This is what harmonic mean is. Harmonic mean यही होता है. Harmonic mean यही होता है. Like AP, GP, HP पढ़े हो ना लोग? Shreya, Vanshika, Mohammed, Shashank. अब if you would simplify it, you'll get this formula. These are all just formula. I'm not sitting here and explaining you stuff. ये फॉर्मूला होता है, ये फॉर्मूला है, ये ऐसे ही होता है, बिकॉज ये मैट्रिक्स है. यू कैन नॉट चेंज द फॉर्मूला एंड एक्सपेक्ट कि मेरे को याद नहीं हो रहा है. याद करने की जरूरत नहीं है. इट इज ऑल जस्ट, इट इज व्हाट इट इज. ठीक है, इट इज व्हाट इट इज. सो लेट्स डू व्हाट, लेट्स हेड ओवर. याद नहीं, अरे शशांक याद करने का जरूरत नहीं है. याद करने का जरूरत नहीं है. यू डोंट नीड टू रिमेंबर दिस थिंग. Let us see. Let me actually help you out with some implementation part. Just tell me if it is visible or not. See, हम लोग को ऐसे भी काफी डिफिकल्ट लगा, राइट? क्या क्या फॉर्मूला था, क्या क्या था, भगवान जाने. सब मेरे को याद नहीं हो सकता. कोई याद करने की जरूरत नहीं है. Whenever you are dealing with machine learning stuff, it is important to know what it is. Formula नहीं याद है, कोई बात नहीं, because everything we have it in our library. sklearn में ये सारे चीज हैं. So I expect you should open your notebook, and if it is open, give me a thumbs up. अगर वो open हो गया तो give me a thumbs up. Mohammed has opened. Shashank, Vanshika, Suyash. Perfect. So let us do what? Let us actually implement some. Just tell me if it is visible. Hoy. Let us start with importing some data set. So from sklearn, we can import some data sets. Import data sets. ठीक है, from sklearn dot model selection you can actually, I don't need this part. What I'll need next, you need अच्छा अभी के लिए इतना ही रखते हैं. And let's have this logistic regression from sklearn dot linear model होता है ना. तुम डॉक्यूमेंटेशन पे भी रेफर कर सकते. लेट मी ओपन द डॉक्यूमेंटेशन. sklearn. You can refer to this documentation. अब तो इतना बार हो गया कि अब याद हो गया. From sklearn lot.linear model import logistic regression, and you may import this accuracy score also, no issues. Let me run this thing. Disconnecting. Yes, it is done. Okay. Now we have actually imported all the requirements. Let us do what? Let us have some data set. So अभी तक हमने binary classification देखा है ना. Let us do with some other kind of classification. You have this, if I can recall it nicely, let me show you here. If I can recall it, there is this data set. If I open this, क्या हमारे पास कोई classification के लिए है? क्लास आइरिस. अच्छा ठीक है, विल चलो फिर इसी को यूज करते हैं. आइरिस डेटा सेट यूज करते हैं. विल यूज दिस. चलो, so how we gonna import our data set? We'll use this function, dataset dot load iris. ठीक है, we'll use this function. Let me have my name iris, dataset dot load import iris. Let me run this thing. Let's see if it works. Yes, it works. So let us see what all features do we have. हमको ये भी देखना है क्योंकि देखो अभी तक हमने डेटा फ्रेम में नहीं यूज किया है. हाँ, अभी तक हमने डेटा फ्रेम में इसको यूज नहीं किया है. So you can see here there are different outputs you can get. You can have this data, you can have this target, you have this feature names, your target names, ठीक है, your frames. These are all what you may expect. So let us use this feature names. Control C. Let me go here. Let us have this. So these are all the features: sepal length, sepal width, petal length, and petal width. These are all your features. Because हमको याद है एक आदि ने एक क्वेश्चन पूछा था मेरे से कि how do we get to see all the data? These are all the data. How can I see? What do I have to predict? You have this target underscore name. और तुम इसको यूज करोगे तो यू विल गेट कि तुमको क्या एग्जैक्ट तुमको आउटपुट चाहिए. तो योर आउटपुट शुड बी either your data would be belong to this setosa or versicolor or virginica. These are the three kinds of iris flower. ठीक है, तो हमने बाइनरी क्लासिफिकेशन को थोड़ा चेंज किया. नाउ वी आर डीलिंग विद मल्टी क्लास क्लासिफिकेशन. यहाँ पे तीन तरह का क्लासेस है. either your input should be a setosa or versicolor or virginica. ठीक है, आगे बढ़े. इतना कर लिए सब कोई? इतना कर लिए सब कोई? लेट अस
एक बार रुक जा, बस थोड़ा सा नोट कर.
शशांक आगे बढ़े. चलो यहाँ देखो, अब हमको डेटा सेट मिल गया. अब हम जो नॉर्मल प्रोसीजर करते हैं डेटा सेट के लिए कि हम डेटा सेट को टेस्ट और ट्रेनिंग डेटा सेट में चेंज वो कर देते हैं, क्या बोलते हैं, स्प्लिट कर देता है. तो यू कैन एक्चुअली look for this test train split. You can have this. Let me share it with you. So we'll do what? We'll split the data set in the training data and your testing data. So for that first we have to import this जो हमने already import कर रखा है. If you would see here, we have already imported this. ठीक है. Now let's do what? Let's see how we're gonna import. So to get your data, you have this example. Okay, we'll use this Control C. Let me head back here. Okay. So you have your X features in your training set. You have this X feature in your test set. You have this Y target in your training set. You have this Y target in your test set. Now let's, in place of X, what do we want? We have this iris dot data because हम इसी पे predict करना चाहते हैं, and we have this iris dot target. Iris dot target. These are my X and Y. My test size is 0.2 because हम convention रखते हैं कि 80% will use for training and 20% will use for testing. Because target names, let me show it for target. Let's see what targets are. See, these are your targets: class 0, class 1, and class 2. These are my Y. What are my X? Iris dot, if I could show you this, you will still get, I guess, this part. Okay, let me do it in print function. So see, these are all your target. So these are all your data, and on this set, you want to predict that whether your value should be 0 or 1 or 2. 0, 1, 2 or what? These are simply your classes. Class 0, class 1, or your class 2. That is something I want to predict. So let's run this thing. So yes, your data is now split. I can actually see X underscore train, comma Y underscore train. I can actually see them. You may see these are your training values and these are all your training targets. So this is what that would happen. Now let's do what? Let's build a model to implement logistic regression. So I can simply say my model is equals to, if I could show you here, share this tab. Let us have this linear, linear model. If you go to this linear model, you have this linear classifier as logistic regression. If you click on this, you will have this function which is known as logistic regression. I'll use it. I'll not use this random state. Random state का कोई काम नहीं है. And let us say model dot fit. And what do I want to fit it off? I want to fit my X train and Y train. Let's run this thing. So now you are ready for logistic regression. You have actually made that model. Now let's do what? Let's predict. Let's predict now. So Control MB, let's head on to some other values. What I say, let us have two set of variables. Let us have two set of variables. ठीक है, हम ये करना चाहते हैं कि we have our target value, हमको actual values पता है. Now I want to check कि whatever are my predicted values वो accurate value से कितना अलग है. So हम क्योंकि हम डेटा सेट को दो पार्ट में डिवाइड कर चुके हैं, ट्रेनिंग और टेस्ट में, तो दोनों के लिए प्रेडिक्शन निकालते हैं. Let us have X train underscore, let us have predicted. So how can I do it? We have this function model dot, if I'll show you here, you have this predict function, I guess. Yes, you have this predict class label for the sample X, whatever X you will provide, उससे corresponding logistic regression के through it will predict. Dot predict X train. Let's print those values. So these are all my predictions. Let us do it for Y test predict. I'll simply say model dot predict, and I want to do it for X test. Let me run this thing. So now you are good to go with your predicted values. हमने ट्रेनिंग सेट के लिए निकाल दिया, हमने टेस्ट सेट के लिए निकाल दिया. ठीक है, ठीक है, just tell me ठीक है. So let me share this tab. If you will see here, there is this sklearn.metrics. So you have इतना सारा kind of metrics. If I'll open this, you have this confusion matrix. देख रहे हो यहाँ पे confusion. अच्छा इसको थोड़ा. So see इतना सारा values है. You will have this confusion matrix. We'll use this. So I have to import this thing. How can I do it? If you can see here from sklearn.metrics, just a second. Let me use it in our code. See, just tell me, documentation से पढ़ाना ज़्यादा easy है ना? Like तुम लोग भी समझ पा रहे हो कैसे क्या psychology रहता है to work with it. Just tell me if it is true or not. So let's run this thing. Now it is time. Now what I want, if you could just see here, to get your value, you want something like, you have to use this function, confusion matrix, in which you will put on what values do you want to make it of. Let us do it for these two values. हमारा अलग है ना, हमारा predicted है, चलो कोई बात नहीं, चलो वहां पे put कर देंगे. We'll simply copy this. Because see यहाँ पे भी, if you will read the documentation, इसने भी एक y predicted निकाला, which are true, and y predicted and y true, इसने दो निकाला. हम लोग थोड़ा सा change करेंगे. We'll also use something on the similar lines. I have this y train. Let us do it for training one. Train underscore predicted. Let us make a matrix. So you have this matrix now. Remember 3 classes थे, तो you have this 3x3 matrix. The first row belongs to your, अच्छा, let me 40, 38, 3, 0, 39. Let me make it here. Just tell me if it is visible or not. Present it. Not. Just a second. If I'll use this, oh, my mistake, मैं वो share नहीं किया था. I'll use this function, confusion matrix, and in confusion matrix, I want to check whatever we have predicted, how much it differs from our actual training value. If I'll run this thing, you'll have this. Control MV. Let me do it for our test value. Y test. You have this another matrix. Okay. So let me actually open my OneNote and help you out figure with that. Just tell me if it is visible or not. What was the actual matrix? Okay, first we have your training data. उसके लिए करते हैं. Let's make it. You have this class 0, you have this class 1, you have this class 2. These were the 3 different classes. Your predict, let's say 0, you have this predict 1, you have this predict 2. These were the 3 different classes. So it was 40, 0, 0, और क्या था, तुम्हारा हो सकता है कुछ डिफरेंट वैल्यू आए, कोई इशू नहीं है, बिकॉज हमने रैंडम स्टेट वहां रखा हुआ है, तो वो रैंडमली इसको शफल करेगा, कोई जरूरी नहीं है कि वो सेम वैल्यू आए। तो अगर ऐसा नहीं भी आ रहा है कोई दिक्कत नहीं। 0, 38, 3, 0, 0, 39. So this was your matrix. What does it says? क्या कहता है ये कि out of, like you can add 40 plus 0 plus 0, out of 40 values सारे के सारे correctly predict हो गए हैं. All of them belongs to class 0. 40 of them has been accurately classified. In class 1, 38 plus 3, 41. So out of 41 data which belongs to class 1, only 38 of them has been classified correctly. बाकी 3 class 2 में belong करते हैं. That is what our prediction says. If you take off a class 2, out of 39 data set, 39 plus 0, 39. So out of 39 data set, all of them belongs to class 2. That is what our prediction is. So I assume you can use these are formula here. You may use all these formula जो यहाँ पे तुमने देखा, ठीक है, you may use all this formula to calculate the actual values. So अब one question arises कि भैया इतना बैठ के कौन काम करेगा, कौन इतना बैठ के एक एक मैट्रिक्स को ओपन करेगा and he'll do all this stuff? No one will. So one important way to actually ignore this thing is, let's go back to our documentation. You have this classification report. Let us do what? Let us import this first. Let us import this from sklearn.matrix. You may import it. And all you have to do is you have to just simply use this function. If I could show you here. See, that is what I said. Documentation के साथ सब easy हो जाता है. What you have to use just this print function. अब देखो हमने labels तो provide किए नहीं है, तो we don't provide this label. और हमारा यहाँ true और ये तो है नहीं, हमारा यहाँ पे कुछ इस तरह से है, y train और उसके corresponding उसका prediction. Let's print this stuff. So you see you have this kind of summary kind of thing. पहला का precision it is 1, दूसरे का precision it is 1, third it is for class 0 का precision is 1, first का class 1 का भी 1 है, precision of second class second is 0.93. You have this recall figure, you have this F1 score. These are all your accuracy, your average, macro average, and your weighted average. So using this matrix, you can simply get whatever you want. You can also do it for your other. Control C. Let me do it. Let me do it for your test values. जो तुम्हारा टेस्ट वाला जो डेटा सेट था उसके करस्पॉन्डिंग हमने कुछ प्रेडिक्शन किया, एंड दिस इज व्हाट यू गेट. Your precision is 1 for all classes. Your recall is 1. Your F1 score is 1. Your accuracy is 1. ठीक है. So I guess इतना पार्ट क्लियर हुआ. शशांक, सुयश, मोहम्मद, was it clear till now? Okay. So you may actually go out here and you can have different attributes. You have all these different attributes. You may actually work with them, no issues, whenever you need. Now let's go back. Let's go to our another important topic, feature scaling. एक्चुअली देखो मेरा मैंने जब बैठ के अपना सिलेबस टाइप का बना रहा था ना, ये जो तुमने रिसोर्सेज देखा होगा, कंटेंट प्लान, I was actually planning to do it in the very first few weeks, but then I decided I'll rather put it towards the late, because as expected, I was not expecting people to actually go for machine learning. ज्यादा अधिकतर लोग DS ये वेब डेव वाले लोग हैं, but as expected we have few people here, so I want to keep some very important things for people जो last तक बने रहेंगे. So feature scaling is one of the very important part of data pre-processing. अभी मैंने मॉडल कुछ नहीं बनाया है, अभी तक मॉडल मेरे को नहीं पता मैं क्या करूंगा क्या नहीं करूंगा, मुझे कुछ नहीं पता. I don't know anything. All I have is my data set. All I have is my data set. So data pre-processing, if you can recall, it was the first step for your machine learning. There was this machine learning cycle. So once your objectives are done, this was the first step after gathering data. Once you have your data with you, you actually pre-process it. So if you can see the definition, it is an essential step in data pre-processing. अब होता क्या है, let me actually tell you one thing. Let me actually tell you one thing. Okay. Let us say our aim is to predict house price. ठीक है, और let us say, हाँ, our just a second, let me erase it. Our aim is not to predict house price. Let us do it for classification only. हम classification पढ़ते हैं. Our aim is to classify a house in, let's say, for poor people, for middle class people, and for rich people. ठीक है, हमारा whatever features we would be having, on that feature we want to predict कि हमारा जो घर है, क्या वो घर it is for poor people, or whether it is for middle class people, or is it for rich people. Let us predict for this. Let us see what features do we have. For example, we can have something as its location. ठीक है, we can have a location, we can have number of bedrooms, right? Area in square feet. You can have something as income. Yes, you can have something like this. If you could see, if I like to put some random value, let's say the location is 78 degree latitude, 28 degree longitude, for example. Number of bedroom, let's say we have 4 bedrooms and we have 1000 square feet, and the income is somewhere around 80,000, for example. We have some other data set. The longitude is 24 degree latitude and 36 degree longitude, for example. These are all arbitrary values. Number of bedrooms are something of the order, let's say 2, and your area is, let's say, 7,000 square feet, and your income is only 12,000, something like this. So you may see, अगर तुम इस example में देखोगे, and if you could recall this equation, ये equation याद है सबको? Regression equation था, और if I could like write it something like that, beta transpose X. So just tell me one thing, if I like to put all these features, मैं एक general overview दे रहा हूँ. Let us have something as your beta naught plus beta 1 into, let's say, your number of rooms. So number of room is 4, for example. Beta 2, then comes your square feet, 1000, plus beta 3, 80,000. ऐसे something like this. So अगर तुम इसमें बहुत ध्यान से देखोगे तो you can say ये एक इकलौता ऐसा फीचर है जो ये सबको ओवर पावर कर दे रहा है. हो सकता है ये सब का जो वैल्यू ये बहुत छोटा हो इसके रिस्पेक्ट में, राइट? What I'm saying that this 80,000 is overpowering all these features, right? Can I say Suyash, Shreya, Vanshika, Mohammed, Shashank, are you getting मैं क्या बोलना चाह रहा हूँ? Or you may have something like this, or you may have something like कि if I also like to take in account this value, हो सकता है किसी का longitude 247 point something हो, beta 1 of something like this. तो हो सकता है ये अकेला फीचर सबको ओवर पावर कर दे, राइट? अच्छा, let us take it for 3 example. Let us take the placement wala example. Let us take it for placement wala example. So you have this age of a person, you have this IQ, you have this CGPA and placement. Yes, yeah, no. So just tell me, if my age is, let's say, 18, my IQ is somewhere 132, my CGPA is, let's say, 6.8, and let's say my placement is yes. Okay. If my age is 22, my IQ is 66, my CGPA is 9.2. हो सकता है मैं प्लेसमेंट नहीं हूं, हो सकता है. We have, let's say, some other example. My age is 26, my IQ is 1110, my CGPA is 8.5. हो सकता है मेरा प्लेसमेंट हो, right? So you can see from here, this value is this IQ feature is comparatively bigger than this age and CGPA, right? Like if I'm using logistic regression, if I could make you recall this, logistic regression was what? 1 over 1 plus e raised to the power minus beta transpose x. So if my beta is, if you take in beta, ये value बहुत ज़्यादा बड़ा है with respect to this and this. So I can have this assumption, I can have this intuition that to predict whether a person is able to be placed or not, IQ is overpowering the other two features. ये दो feature को overpower कर दे रहा है. Can I say, Mohammed? Can I say Suyash like this? Although chances are that my placement is somehow dependent on my CGPA. Ignore these two values. It is somehow dependent on my CGPA. Let us have this. But this IQ is doing what? It is actually overpowering the rest of your features. So in order to avoid such thing, we use this feature scaling. What it does, that it involves adjusting the scale to ensure that all of them contribute equally to the performance. जैसे अभी तुमने देखा, एज से भी बड़ा वैल्यू था तुम्हारा IQ. So I can have this intuition that in order to predict, in order for my model to perform this feature, which is your IQ, it is overpowering the rest of the feature. और आई कैन से मेरा जो बाकी फीचर है वो उतना अच्छा से कंट्रीब्यूट नहीं कर पा रहा है, राइट? कैन आई से शशांक? वंशिका? वंशिका? परफेक्ट। बट when we are ये तो अभी एक एग्जांपल है, बहुत सारे एग्जांपल तुमको मिलेगा, लाइक स्पेशली जब हम डील करेंगे विथ दिस क्लस्टरिंग एल्गोरिथम। फॉर एग्जांपल अभी ये बेडरूम का जो एग्जांपल दिया, I can have some data like we can for some values, let us have, if I classify it for rich people, if I classify it for poor people, let us have, but you may say एक पुअर बंदे के पास 7,000 स्क्वायर फीट का घर क्या कर रहा है, but since it is overpowering the rest of them or your income is overpowering, you may ignore the fact that वो पर्सन के पास सिर्फ 2 ही बेडरूम है, राइट? राइट? नहीं समझ में आया? व्हाट आई मेंट वाज कि लेट्स से दिस हाउस बिलोंग टू अ पुअर पर्सन, ठीक है? तो तुम एक बायसनेस के साथ ये कह सकते हो, अच्छा सिर्फ घर में 2 रूम है तो ठीक है, ये गरीब के पास ही होगा, किसी एक पुअर, आई एम यूजिंग इट फॉर एग्जांपल ओनली, since it has only 2 bedroom, it should be belong to some kind of poor people, but you have ignored the fact that it has the biggest area, right? तुमने ये फीचर को देखा ही नहीं, इस फीचर को देखा ही नहीं कि इसका इनकम सिर्फ 12,000 रुपए ही है। तो बेसिकली तुम कह सकते हो कि मेरे पास ये जितने सारे डिफरेंट फीचर्स थे, तुमने इसको ओवर पावर कर दिया इस एग्जांपल के लिए पर्टिकुलरली। बट वी वांट कि हमारा सारे जो फीचर है वो इक्वली कंट्रीब्यूट करें विदाउट एनी बायस। दैट इज व्हाट हैपेंस, बिकॉज सी अगर हम फीचर स्केलिंग नहीं यूज करेंगे तो देयर काइंड बी सम काइंड ऑफ बायसेस जिसका मैग्नीट्यूड ज्यादा हो, ठीक है? सो टू एक्चुअली मेक एवरीथिंग यूनिफॉर्म, सबके लिए इक्वल कर दे, यूनिफॉर्म स्टेज कर दे, वी यूज दिस कंसेप्ट व्हिच इज नोन एज फीचर स्केलिंग, ठीक है? Like why it is important, you may have this, it improves the model performance obviously। जब सारे फीचर्स जो इंपॉर्टेंट फीचर्स है वो वर्क करेंगे एक साथ, तभी मॉडल अच्छा वर्क करेगा। यू हैव दिस फेयर कंट्रीब्यूशन एंड we'll see when we'll have this distance based algorithm, we'll see क्या होता है इस पे। मैं थोड़ा सा एक्सप्लेन कर देता, चलो ये भी बता देता हूँ। लेट अस हैव दिस your age, your CGPA, and your placement or your package. Let us have it for package. Let's say your age is 22, your CGPA is 8 and your package is 7 LPA, ठीक है? Let us have your age as 23, your CGPA as 4, and you want to predict कि क्या ये होता है। We can have something as 25, your CGPA is 9, and let's say you have 9 LPA, or let us take it for 3 LPA for example. So if you use some, there are for example we have this k nearest neighbor algorithm। इसमें क्या होता है कि you have a point and you have this another point। हम क्या करते हैं कि we want to see कि ये किसके सबसे नजदीक है। like if this class is for, let us say if this is for class some cat, so if this figure, अगर ये जो distance है, let me do it with some other pen, अगर ये जो distance आ रहा है, if this is very close to cat, chances are कि ये जो figure है this is for cat। if you have this, let's say dog, I'll calculate this distance, I'll calculate this distance, and I can see this distance is closer, it is less, so I can say that this figure is of cat। इस तरह से हम use करते हैं। and you may have two kind of distances, Euclidean and Manhattan, जो हम उधर discuss करेंगे। so if you would use that here, if you would use that here, you may see that the,
संजय ग्राफ वाला एक बार बता दो जरा, ग्राफ पे जो बताया वो
ये
आवाज
देखो,
धीमी थी।
ये मैं बस अभी एक्सप्लेन कर रहा हूँ, लाइक हाउ डू KNN वर्क्स. So there are some distance based algorithm. Let us have this figure for some dog. Let us have this figure for some cat. अब तुम्हारे पास एक डेटा पॉइंट है ये. अब तुम क्या करोगे, तुम्हारे पास ये दो लेबल है कैट और डॉग का. तुम देखोगे कि किसके नजदीक है, तो यू में कैलकुलेट दिस डिस्टेंस. ये डिस्टेंस कैलकुलेट करो. दिस इज D2, दिस इज D1. तो यहीं पे मेरे को दिख रहा है कि D1 इज लेस देन D2, राइट. तो आई कैन से दैट A इज माई डॉग. ये इसके नजदीक है ज्यादा, तो इट इज अ डॉग. अब होता ये जैसे हम यूक्लिडियन डिस्टेंस यूज करते हैं, तो इट इज समथिंग लाइक x माइनस x हैट स्क्वायर प्लस y माइनस y हैट स्क्वायर. सिंपल मैथमेटिक्स. अब चांसेस आर, टेल मी, अगर इफ आई रिड्यूस x एंड इंक्रीज योर y, चांसेस आर कि मेरा वैल्यू जो होगा वो सेम होगा, कांस्टेंट होगा, आसपास होगा. लेट्स से इसको मैं 2 यूनिट से सब्ट्रैक्ट किया, इसको 2 यूनिट से इंक्रीज किया, तो चांसेस आर कि अभी भी मेरा जो वैल्यू है वो आसपास ही होगा इनिशियली जितना था. हो सकता है, हो सकता है, हो सकता है. लेकिन जब हम ऐसा करते हैं तो हमारा प्रेडिक्शन करेक्ट नहीं होता है. विल सी इन KNN. मैं भी एक इंट्यूशन देने का चाह रहा हूं, बिकॉज हो सकता है कि ये वैल्यू बहुत बड़ी हो जाए, ये वैल्यू बहुत बड़ी हो जाए, तब जिसके कारण क्या हो कि ये फीचर को हमने इग्नोर कर दिया. सॉरी. So in order to avoid all this kind of discrepancies, we use this feature scaling. We will use this feature scaling. अब वही यहाँ पे मैंने डिस्कस किया है तुम लोग के लिए कि for distance based algorithm, feature scaling is important. You may actually see when we use it before your training model or during cross validation or while testing your data. What impact does it have if you use it for linear regression? If you will use it for linear regression, what would happen? That convergence, that gradient descent would happen very fast. बहुत जल्दी gradient descent हो जाएगा, and you will get the optimal value for M and B. If you will use it for logistic regression, same thing happens. Your convergence would happen very fast. You would not have to go for बहुत high epochs. You will have it in less epochs. So let us actually see what it is. See, whenever we are dealing with feature scaling, there are 4 to 5 kinds of feature scaling methods. The first method is known as your min-max scaling. Or sometimes this is also known as normalization. होता क्या है ये? When do we use? Like when do we use? हम इसको यूज कब करते हैं? Whenever we want our data to be in this range, either 0 to 1 or your -1 to 1. जब हमको डेटा इस रेंज में चाहिए होता है, whenever whatever feature you may use, whenever we want it in this range, we use it. What is the formula? What is the formula? You may ask. So formula happens to be, if I'm talking about your ith feature xi, if I'm only talking about your ith feature, ठीक है? If I'm talking about ith, see what it is. This is your ith feature vector. ठीक है? What it would happen, what it will do is, I want to get this range either 0 to 1 or -1 to 1. So the formula happens to be xi minus minimum of this xi divided by just a second, divided by maximum of this xi minus its minimum. This is the formula. Because whenever you will compute this thing, you will always get a value which is between 0 to 1 or minus 1 to 1. Okay? You'll always get, this is the formula. We have this another feature scaling method which is known as maximum absolute scaling. What is the formula? These are all formula stuff. Xi, you can have xi and you can divide it with maximum value of this xi, and if you like to take some mod you may take it. Just a second, इसको अच्छे से लिख दे दो. This is your mass absolute scaling. We'll see अभी जब हम इसको implement करेंगे तब थोड़ा और clear होगा. We have this third scaling method which is known as standardization, or in some book you may see this Z score normalization. In some book it is Z score normalization. इसमें क्या होता है? This is very interesting. What it says is your xi would be equal to xi minus your mean divided by your standard deviation, where this mu is your mean and this would be somewhere around 0. Is your standard deviation, and this would be around 1. This is the formula. Then you have something which is fourth one, which is known as your robust scaling. What is the formula? What it does, xi is equals to xi minus median of all xi's, and you divide it by interquartile range IQR for xi. This is the formula. अब you may say कब हम इसको use करते, तो see, we use it whenever we don't have some kind of Gaussian distribution. Gaussian distribution is something like of a bell curve. Bell curve I guess सबने इस तरह का curve देखा होगा. देखा है? वंशिका, श्रेया, सुयश, मोहम्मद. This is your Gaussian distribution. जब हमारा डेटा इसको फॉलो नहीं करता, दिस इज अ बेल कर्व. So we use other kind of, like you have this max absolute scaling, we use it there only. ठीक है? So this was your formulas. These were your formulas. Like you have this, if I could show you here, you have this Z score. So you may say, when do we use Z score? It is pretty obvious. Whenever you have a data in which you want some kind of normal distribution, some kind of Gaussian distribution, whenever you need it, तो तुम ये इसको use कर सकते हो. When do we use this robust? अब जहां पे ये IQR आ गया, I can understand कि उस डेटा में कोई ना कोई extreme values है, कोई ना कोई outliers है. So then we can use it, no issues. So actually let's head back and implement it. Let us head back and implement it. Let me use my, let me open a new notebook. इतना पार्ट क्लियर हुआ? These are all just formula जिसमें कुछ हम कर नहीं सकते. अब ये formula ऐसे ही दिया हुआ है. ठीक है? शशांक, वंशिका, सुयश. Let me actually open it. Feature scaling using wine dataset. We'll use it. Chalo. Just tell me if it is visible or not. Give me a thumbs up if it is visible. So let me actually use that dataset. मेरे पास है यहाँ पे नहीं है. Just give me a second. Let me actually load this dataset. Just tell me. अरे एक मिनट, ये ऐसे कैसे हो गया? Just tell me if it is visible or not. Fine. So what we have done, we have simply loaded this dataset. Okay, so let's start with feature scaling. So we have a dataset. Let us import it first. So in order to import it, you have this import pandas as PD. We'll have okay, control MB. Let's have a load our dataset. Let me have my wine is equals to PD dot read CSV. Read CSV, and in that I'll pass my address. Can use this copy path, pass it here, and now your data set is ready. Let me see what my data set is. Wine.head. This is what your data set looks like. अच्छा, इसमें columns नहीं है. Let us add some columns. Let us add some columns. ठीक है. Let us have your column names. Columns should be. Let us put some column. This is whether it is one होता है I guess alcohol के लिए. If I'm safe to if it is safe to assume. So my first is your alcohol. Second one is I guess malic acid. Just a second, let me check it. Wine dataset feature. What are the different features we have? So if I could share you this, these are the different kind of attributes we have. ठीक है, I'll just put it there. कोई issue नहीं है. I'll have to type it out, but ठीक है. So you have that malic acid. You have that क्या था? Ash. ASH. You had that alkalinity of ash. I'll use the same. मैं type it out. थोड़ा सा data set में गलती था मेरा. You have this magnesium. You have this total phenols. मैं वही ये data set को देखो यहीं से copy कर रहा हूँ. You can go for the geek wine data set. You have this total phenols. I'm copying it up. Because we want some kind of columns, right? Column name के बिना तुम क्या work करोगे? Pretty safe to assume. This non-flavonoid phenols जो टाइम लेगा यही लेगा उसके बाद ही से. You have this polyanthrocyanins. Control C, Control V. Let's head on to the next feature. कलर इंटेंसिटी यही सब था ना? हाँ यही सब है ना? हाँ यही सब. Let's. So your it was color intensity, I assume. Perfect. बहुत झंझट है. So हाँ, I have this. Let me copy it for you. Let me copy it for you. You may actually type this same code here. You may actually do it. Now let's do what? In our pd.read CSV, we'll pass this thing. X, we'll pass it here because first we have assigned. So since this was my data set, I can have my names to be my column. Let's run this thing. Now you have all these attributes. आया सबका? आया सबका? Just give me a thumbs up अगर आ गया हो. Then only I can proceed आगे. Vanshika says yes, Shreya says yes, Shue says yes. Perfect, perfect, perfect. थोड़ा सा डेटा सेट में ध्यान से नहीं दे पाया, सॉरी माय मिस्टेक. हाँ तुम ये भी कर सकते हो कि sklearn में भी वाइन लाइब्रेरी है, वाइन डेटा सेट है, यू कैन ऑल्सो यूज दैट. मैं इसलिए करा रहा हूँ बिकॉज आई वॉन्ट यू टू मेक यूज ऑफ दिस फंक्शन. ठीक है. नाउ लेट्स डू व्हाट. इफ आई कुड शो यू दिस थिंग. गलती से ही सीखने मिलता है. अरे यस. See, if you go to this section, you have this pre-processing library. You may open it. Now you have all these different kind of scaling features. Like you have min-max scaler, max absolute scaler, as I have told you. You have this min-max scale, normalize, you have this scale, you have this robust scale, सब इसमें दिया हुआ है. It is all that quantile transformer सब यहाँ दिया हुआ है. It is all this कि हमको क्या use करना है. We'll just figure it out from here. So let us see some kind of scale. Let's go for this. Let us use this. सबसे पहले. So before anything, we have to import this library. Control C. We'll go back here. We'll import it straight away. We'll straight away import it. ये वर्क करेगा? अच्छा नहीं, रुको, ऐसे नहीं करते. हमको sklearn पूरा प्री प्रोसेसिंग पूरा चाहिए ना. तो we'll say from sklearn import. What was the name? Pre-processing, na? Pre-processing, yes. Let's run this thing. So it has installed all the different normalize scalars you need. So we can have something as, let's say your x, let me take it for x, is equals to pre-processing pre-processing dot scale, and you can pass this wine here. Let's print this. So now you have this array. 1 से लेके कुछ के बीच वैल्यू वैरी कर रही है. Let us put it in some kind of again I want to change wine is equals to pd dot data frame. Let me put it there as my x, and I want my columns to be my columns. Columns is equals to columns, because that was what my name was. Let us see our data set. So now your data set has been scaled. अब ये जो सारे वैल्यूज हैं, ये ऑलमोस्ट एक रेंज के बीच में ही वैरी कर रहे हैं, राइट? इट इज ऑल वैरिंग बिटवीन अ पर्टिकुलर रेंज. अब इफ यू कुड रिकॉल हेयर, यहाँ पे देखो, दिस अल्कोहल वाज 14, your malic acid was 1.71, this proline was 1065. So technically this proline was able to outweigh every other feature here. ये इकलौता फीचर सबसे हैवी था. if I'm talking about magnitude, right? If I was talking about magnitude, this feature proline was very large in the magnitude. बाकी सबसे कंपेयर करो, कहाँ ये 3 है, कहाँ ये 127 है, कहाँ ये 1 है, और कहाँ ये 1065 है. But see what happened? Each of your value has been transformed into a kind of similar scale. अब हुआ ये कि now you are actually able to predict with much better accuracy. ठीक है? Sorry. So this is what scale function. This is what scale function. If you could see here, what it says, it standardize your data set along any axis, because whatever the mean is, it will center it around the mean. ठीक है? इतना क्लियर हुआ? इतना क्लियर हुआ? अब you can use it for this thing. You may get your values. Now let's do what? Let's do for some other characteristics. We can have something as min-max scalar. Your min-max scalar. Let's see min-max scalar. Control MB. Let's head on to something. If I, let's see, मेरा wine के साथ कुछ हुआ है अभी भी? मेरे ख्याल से मेरा wine change हो गया होगा अब. हाँ, wine change हो गया. चलो ठीक है, कोई बात नहीं. We'll simply do the same thing. We'll have something again as this. wine 2 कर देंगे अब की बार. wine 2 कर देंगे अब की बार. Okay, Control Z. Let's head back to the next. I'll do this, wine 2, and let me print wine 2 dot head. Now my data is good. Now I want to implement my min-max scalar. So what you have to do, you may just see here.
Shrinjay, तुम्हारी screen pause है.
See what I did. मेरे को डेटा, मेरा ओरिजिनल डेटा तो अब चेंज हो चुका है अल्कोहल वाला. What I did कि मैंने दूसरा एक डेटा सेट बनाया, सेम वही चीज कॉपी कर दिया. अब आया माई ओरिजिनल डेटा सेट. ठीक है, जैसे मेरा इनिशियली था. ठीक है. Now let's implement min-max scalar. If you could see here, let me show it to you. You have this min-max scalar. So see how does it works. It actually transforms each feature in a given scale. So let us see how do we implement it. So since we have already imported our pre-processing, we'll simply use it. How do we implement? Let us have something as min-max scale, min-max ही रखते हैं. So it is as easy as your function which we have here. If I could show you. अच्छा, इसमें नहीं दिया है. चलो कोई बात नहीं. We will use the way we have done it earlier. So it is pre-processing dot min-max scalar. We'll not use it a bit. So once I use it, my data has already been scaled up. Now let's do what? Let's print this thing. Yes, you're now good to go. Let us do what? Let's see if we fit wine here, what do we get? अच्छा ऐसे नहीं मिलेगा, चलो let us transform first. If I show you here again, if I show you here again, we need some kind of transformation. Let us see, do we have any transformation here? Transform. Huh. We have this attribute transform. What does it do? It scales your feature in according to whatever feature you whatever range you give it. ठीक है, ये क्या करता है, इनपुट डेटा लेगा, उसको जो हम रेंज प्रोवाइड करेंगे उस रेंज में स्केल कर देगा. दैट्स इट, कुछ इसमें रॉकेट साइंस नहीं है. So you have this again. Let us do it in your data. Wine2 is equals to your minmax dot fit transform. I guess fit transform था ना. अच्छा पहले fit transform देखते, fit transform देखेंगे पहले. fit transform, let me show you here what it do. fit transform पहले डेटा को fit करेगा उस स्केलर में and it will transform it. You can also use it first you transfer get the data, you scale it up, and then you may use transform function. No issues. I'll use this. And what do I want to transform? I want to transform this wine2 again. ठीक है, I want to do this. Can I have this wine2? I guess again वो ऐसे ही रहेगा. You have this array again. So now your data set has been transformed using min-max scalar. Min-max scalar, if you could recall, x minus min by max minus min. So on that, अच्छा इसको data frame में कर देते हैं, easy रहेगा. So I can again have this wine3 is equals to pd dot data frame, and I'll put this wine2 and columns. हाँ चलो ठीक है, I'll put wine2 and I'll put the column. Let us see. So now you can see using the min-max scalar again you get the same thing. Now the data has been transformed again using that formula, x minus min of x divided by max of x minus min of x. So for all different features it has calculated it and it has made this. So now if you work on this data set, you will have a much better output. So you can actually do what, make it till here only. इस डेटा सेट पे you may apply logistic regression. एक बार बिना इसके लगा के देखना, एक बार लगा के देखना, and get the scores, accuracy score check करना. Get the accuracy scores there. इसमें ज्यादा आएगा. वो पार्ट में डिस्कस नहीं करूँ because already it's too late. 11:10 we'll not discuss that part, but I assume कि ये तुम लोग को समझ में आ गया होगा. You can also have something like wine dot transform. You can simply transform it, no issues. You can also go for some other transformations like max absolute scale. You may also implement it, no issues. ठीक है, so should I assume कि whatever I taught you it was clear to the extent जितना होना चाहिए? 100% नहीं आएगा I assume, because इसमें बहुत ज़्यादा implementation था, बहुत ज़्यादा formulas था. उसको हटा के if I give you this data set, now you can actually do what? You can resume from here and now you can actually build the logistic regression. और जितना data set मैंने अभी तुम लोग को provide किया है, you may actually go on, implement all these transformations, scaling, feature scaling, and then do the regression part. You will have a better output. So should we wind up today's session? Should we wind up today's session? Should we wind up? Okay. So Yash, since तुम first time class attend किए हो, you can actually go on the WhatsApp group. You can see the resource link in which in the drive I have given all the PDFs and PPTs and books which you would need to read. In the YouTube link I have given the playlist. हमारा ये 13th class है. In the in first 2 weeks we have seen Python. From week 3rd we have seen linear regression, multivariable linear regression, logistic regression, this classification measure and feature scaling, and we will have another class maybe tomorrow or day after tomorrow on decision trees. Then we have completed till week 3. Okay, perfect. So should we wind up today's session? Perfect. So if you have any query, feel free to drop me in the group. I'll happy to answer. Till then, we'll meet you in next session. Good night, everybody.